Okay, so now let's go back to this apparent paradox that you're probably thinking of. Alice and Bob are in two frames, say two spaceships, or let's say Bob is on the ground, Alice is in a spaceship. It doesn't matter. What's important is that they're co-moving relative to each other. Alice says Bob seems to do everything slowly. His clocks seem to run slowly. So when my clocks do 2 ticks, his clocks do only 1. Bob, on the other hand, says, well, Alice seems to do everything slowly. Her clocks seem to run slowly. When my clocks do 2 ticks, hers do only 1. So is one right or the other, and the other wrong? And of course that can't be, because that would violate principle of relativity. To say that one is right and the other is wrong is to break the symmetry of the situations, right? It is to say that one is moving and the other is not. And principle of relativity says that motion is only relative. One is only moving relative to the other. So then how do we resolve this issue? First, note that Bob uses his 2 clocks separated by some distance, L, to time Alice's 1 clock. Remember, I emphasized that we are comparing the time between 2 events that take place at the same location in Alice's frame to the timing between those same 2 events that obviously don't take place at the same location in Bob's frame, because Alice is constantly moving relative to Bob. So Bob has to use 2 clocks, and he has to synchronize them, okay, according to him. But what's synchronous according to Bob is not synchronous according to Alice. So Alice will say, of course, Bob thinks that it took me longer to finish lunch, or that it took me longer for the clock to go from 0 to 1, because his clocks are not synchronized. Okay, so let's see how that works. So this is Alice, and here's her clock. She's sitting at the back of the spaceship eating lunch, or let's stick to clocks. She's sitting at the back of the spaceship, and there's a clock that goes tick, 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 and here's Bob. Okay, so this is Alice. She's sitting inside the spaceship. It's moving with speed v, and this is Bob. And Bob has to time the two. He has to time the interval of time between her clock striking 0 and her clock striking 1. And he has to do that with his 2 clocks, because by the time her clock strikes 1, it will have moved. Okay, it will be somewhere here. And when that clock strikes 1, boom, there better be a clock located in Bob's frame ready to record the time of that event, because remember, that's how we make measurements. Whenever there is an event, a clock striking 1, there has to be a ruler and a clock in Bob's frame to record the coordinates and time of that event. That's why Bob has to use 2 clocks. Okay, so I'm going to erase this so it doesn't confuse you. So this is the T0 situation, both frames. So when her clock passes by his clock 1, let's say this is clock 1, this is clock 2, we agreed he has to use 2 clocks. Both of these clocks read 0. This is just the agreement. This is that idea of when the origins of 2 frames pass by each other, we will agree to set clocks located at respective origins to be 0. We can always do that. This is just the agreement. Now here's the key. According to Bob, at that instant, his other clock 2 also reads 0. So the two events, clock 1 strikes 0, clock 2 strikes 0, are simultaneous in Bob's frame. But remember, we already saw that events that are simultaneous in Bob's frame cannot be simultaneous in Alice's frame. That was the consequence of constancy of speed of light. So that maybe at first it seemed like a very mundane thing. So the events that are simultaneous in Bob's frame are not simultaneous in Alice's frame. In other words, Alice will not think that both of his clocks, clock 1 and clock 2, strike 0 at the same time. First one strikes 0 and then the other strikes 0. So which one strikes 0 first according to her? Okay, does his clock 2 read something larger or smaller than 0 at the time when all her clocks read 0? So let's analyze things from Alice's perspective. Okay, so this is from Bob's perspective. This is from Bob's perspective, right? So he's sitting on the ground and he sees her move. Okay, and this is t equals 0. Both of his clocks strike 0. Her clock reads 0. And so he thinks the events are simultaneous. Now, she doesn't think that both of his clocks strike 0 simultaneously. So to help us understand what she thinks, let's jump into her reference frame. So from her perspective, Bob is moving back in the other direction. Okay, so this is Alice's perspective. I jump into her reference frame. Okay, so jump into her reference frame. Okay, so this is her clock, and this is his clock 1. We agreed. They both read 0 at the same time. That's a convention. According to her, Bob is moving this way. So this is Bob's front bumper. And this is right here somewhere where his other clock is located. This is Bob's back bumper. Okay? Okay, so from Alice's point of view, his clock 2 is located at his rear, at his back bumper. And remember what we saw with light. Okay, the arrival of pulses is was simultaneous in the frame of the car, but from the frame of the ground, the arrival of pulse to the back bumper took place before the arrival of the pulse to the front bumper. The event in the direction opposite to the direction of car's motion takes place first. So from Alice's point of view, Bob's clock 2 is located at his back bumper. So his clock 2 is running ahead of his clock 1. So as observed from Alice's frame, his clock 2 strikes 0 first, and then his clock 1 strikes 0. In other words, when her clock is passing by his clock 1, so her clock is passing by his clock 1, and it reads 0, his clock 2 reads something greater than 0. And in order to know that, she has to place her assistant right here. Okay, so this is Alice's assistant. Okay, so that's the conclusion. According to her, in her frame, both of these clocks strike 0 at the same time. Alice looks at Bob's clock 1, she says it's 0. And she's asking her assistant, hey, Alice Jr., please take a look at Bob's clock 2. And Alice's assistant peeks at Bob's clock 2 and says, wait a second, his clock 2 is ahead. It's already ahead. It's kind of fudged. So it's no surprise that by the time, okay, so a little bit later, it's no surprise that by the time her clock reaches his clock 2, it will overestimate the time that it took her. For her, this will, by that point, will read 1. But when she looks at his clock 2, it reads 2. Okay, well, we'll see that again in several instances. So my point was to explain this phenomenon of clocks run at different rate as a consequence of relativity of simultaneity. Let me say a few more words. When Bob says that Alice's clocks run slow, he's referring to a pair of events that are separated only by time in Alice's frame, but by space and time in his frame. Remember, he has to use 2 clocks, time 0 and 1 of her 1 clock. On the other hand, when Alice is saying that Bob's clocks seem to run slow, she is referring to a different pair of events. She is referring to a pair of events that are separated by only time in his frame, but by space and time in hers. You see, constancy of the speed of light forces us to accept that a pair of events that are separated by only time in one frame are separated by space and a different amount of time in another frame. This wouldn't be the case if the speed of light was referred to some absolute frame, like ether, as the case with sound. Then the intervals of time are not related to intervals of space. Time would be absolute. It runs the same time in all frames. So when Alice is passing Bob, he's measuring 2 events that take place at different locations in his frame. When her clock passes by his clock 1, and then when her clock passes by his clock 2. And of course, he has to synchronize clocks, otherwise his timing measurements would make no sense. But because these 2 clocks are separated, they don't appear synchronous to Alice. So this paradox that arises from the statement, moving clocks run slow, can be seen in the context of relativity of simultaneity. What's simultaneous in one frame is not simultaneous in another. And this, in turn, was seen to be the consequence of the constancy of speed of light. Speed of light is the same in all frames. Both observers agreed on the non-simultaneity of sound events because the speed of sound is referred to one particular frame. But they don't agree on the non-simultaneity of light events. Thus, we see once again that the constancy of the speed of light leads to this connection of space and time. I will say a few things more tomorrow. We will look at a problem. We will look at a very famous example, an experimental example of time dilation with a muon. And then we'll do another problem. Then we'll look at the next effect called length contraction. And it will be even clearer why exactly is it that according to Alice, the 2 events are not simultaneous, but according to Bob, they are simultaneous, okay? But what I said today should be enough for you to start digesting, to sink your teeth into this idea of time dilation, okay? So think about it. This is very non-trivial, okay? And the reason it's non-trivial is because the constancy of speed of light is non-trivial, okay? It's very hard to wrap your mind around these things precisely for the same reason why it's really hard to wrap your mind around the idea that no matter how hard you try to catch up to light, speed is always the same value. It's not intuitive. Okay, I don't think I know how to make it intuitive. I don't think anyone knows how to make it intuitive. It was a really strange idea that humanity was forced into, mostly by thinking about electrodynamics. Okay? And that postulate too leads to all these brain twister conclusions that we're digesting through right now. Okay? All right, well, I'll see you tomorrow. We'll continue this.